Hey everybody, so today we are going to start something called the Pythagorean theorem. This is something that's super important. About 2,000 years ago, this cool Greek guy named Pythagoras discovered this relationship between the sides of a right triangle. So that is what we're going to be working with. It's a big concept in math. It is used from here on out for the rest of your life, really, but especially, for the rest of your mathematics career. So we are going to get started. You should have printed out the guided notes that I provided on the agenda, and I think I will try to remember to put them in Schoology as well. So I would print those out first, and we're going to do a little bit of this, and then also I have a few additional problems for you to work on. In addition, you'll have to probably put it on your own notebook paper. All right, so Pythagorean theorem guided notes. Basically, if a triangle is, let's see, I'm going to use purple because I like that color. Okay, a right triangle. And we indicate right triangles by putting a little box in the corner. That means there's a 90-degree angle right here. And that means it's a right triangle. So you'll see that, and you'll especially see that a lot in geometry next year. So that is the shorthand way for mathematicians to say we have a right triangle. So here's what the theorem says. If a triangle is a right triangle, then the square, remember to square something, we are going to raise it to the second power. Okay, so we're going to square the length of the hypotenuse, and that's going to be equal to the sum, so we're going to be adding, of the squares of the lengths of the legs. Okay, I'm going to go back to the first page, the printed out page, and do some labeling that I think might help. So if you look here, you'll see that our triangle has an A, B, and a C. A is considered a leg. It's one of the two shortest sides of the triangle. B is also considered a leg, and the legs make the right angle. I actually find kids mess this up with their A, B's, and C's in math because they get the legs messed up with the hypotenuse. The hypotenuse is leg C, or side C. Hypotenuse. And the hypotenuse always is going to be the longest side of your right triangle, and it is the side that is opposite the right angle. So those are some keys to remembering what is what when we talk about this theorem. Most textbooks and stuff will use a squared plus b squared equals c squared. I honestly, myself, prefer using leg squared plus leg squared equals hypotenuse squared. Just because that makes sure that kids don't mess up with their A's, B's, and C's. They remember that the legs are the two shortest sides of your right triangle, and the hypotenuse will always be the longest side that's opposite your right angle. All right, back to those guided notes. So it says formula, okay, where c squared equals a squared plus b squared. Okay, so this is what you'll see most of the time in the textbooks are a squared plus b squared equals c squared. This is what I personally prefer just to keep the legs and the hypotenuse straight. You're going to square the hypotenuse, and that's going to be the same as the leg squared plus the other leg squared. So you'll hear me refer to it both ways when we talk about the notes. Okay, so C is the hypotenuse, like I said. And A and B are the two legs of the right triangle. Or you might say the two other sides of the triangle. Okay, now we're going to have to be able to work this theorem forwards and back. So next year when you get into geometry, we're going to have a conditional, which is this. If this is the case, then we can say it's a right triangle. The converse says, hey, if we only know the sides, can we prove it's a right triangle or not? So we're kind of working backwards is what a converse does. And the converse of the Pythagorean theorem says this. If a triangle has side lengths A, B, and C, such that c squared equals a squared plus b squared. In other words, the square of the hypotenuse is the same as the square of the two legs added up, then the triangle is a right triangle. Okay, if it works in the Pythagorean theorem and both sides of that equal sign are the same, you have a right triangle. Okay, is a right triangle. If you do that and the hypotenuse, or the longest side squared, or the c squared, is not equal to the other two sides squared and added up, then the triangle is not a right triangle. Okay, doesn't qualify as one of those special right triangles that Pythagoras figured out 2,000 years ago. Okay, so examples. Is this a right triangle? 3, 4, and 5. Now you have to be careful when you do this. Remember, I said in the picture that the legs are the smallest sides. So this one's a leg and this one's a leg. That means the 5 has to be the hypotenuse. Okay, I like to draw a picture. I'm going to put a right angle in here. Okay, and the legs are the ones that form the right angle, and the hypotenuse is the longest side. So this is your A, this is your B, this is your C. So if we were to work this out, we would write c squared equals a squared plus b squared. C squared is 5. A is 3. I'm going to square it. B is 4. I'm going to square it. And I get 25 equals 9 plus 16. And 25 does, in fact, equal 25. So this is a right triangle. Definitely a right triangle. The two legs squared and added up made the hypotenuse squared. Okay? Looking at the next one, let's use the same concepts. Leg and leg, because they're the two shortest. Hypotenuse, because it's the longest. So I'm going to label this A, B, and C. So I want to check c squared. Is that equal to the leg with a length of 4 squared plus the other leg with a length of 6 squared? 9 squared is 81, 4 squared is 16, and 6 squared is 36. Does 81 equal 16 plus 36? And I believe, if we work it out, let's see, that's 30, 40, 52. So no, this one is not a right triangle. Okay. In the first example, we did have a right triangle because the two sides ended up giving you the same answer and they were equal to each other. In this case, number 2, that is not a right triangle. Now, the nice thing about the Pythagorean theorem is we can figure out missing sides as well. So let's look at numbers 3 and 4. And number 3 says, what is the missing number? Okay, nice enough to get my A's, B's, and C's, my A and my B here. So this is a leg, and this is a leg. So here's what I have as a picture. I have a 6 and 11. There's my right angle. And I am looking for the hypotenuse. What am I going to do? I'm going to use the Pythagorean theorem. C squared equals A squared plus B squared. C squared, who knows? That's what we're trying to find. A squared is 6. I'm going to square it. B squared is 11 squared. Let's see. Something times itself should give me 36 plus, I think that's 121. Let's see. 36 plus 121. I got to find my calculator. Where did I put it? Here it is. All right. So I'm going to have 121 plus 36, and that gives me 157. Now, that is not the length of the hypotenuse, because if you think about it, 6 and 11, to have a third side be 157 isn't logical. It doesn't make sense. So we haven't actually solved this yet. We have to, in order to find just one of the C's, we have to take the square root of 157. It's not going to be pretty. So what you do in your calculator is this. You take and hit the second button and the x squared key. Right above the x squared key is kind of this check mark with a long tail. It's called the square root button. I'm going to put 157 in there, close the parentheses, and hit enter. And you probably recognize this is not a rational number because it goes forever and it Never ends and it never repeats. So we are going to be talking, as we move along in this unit, we're going to be talking about how do you simplify square roots like this that don't turn out to be very pretty. Okay? So we'll do the general rule of thumb of rounding to the nearest hundredth. So the nearest hundredth will be 2 spots behind the 2. And we found out that the hypotenuse is actually 12.53. And that would be my answer. Now, keep in mind, if you put that back in your calculator to try to check it, it's not going to be exact because we did have to round this off. Okay, last but not least, and then I'll do some additional examples on another sheet of paper for you. You can maybe just flip this paper over if you printed it off and put them on there. Okay, now I've been given a leg and I've been given a hypotenuse. And you can see the leg is A, so this was 15. And the hypotenuse, whoops, sorry, I meant 4. That's what I meant. Legs are shorter than the hypotenuse. And the hypotenuse is 15. So we can also find a missing leg if we have a right triangle by using the Pythagorean theorem. So I'm going to write it this way this time. A squared plus B squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. And I'm going to put in what I know. I know A is 4. I am looking for the letter B, the other leg, so I will just leave that as a B squared. And I know C is 15. 4 squared is 16. So I'm just rewriting the equation and working out the problems that the information that I have. If I square 15, I get 225. And if we use our solving equation strategies, I'm going to get the B squared by itself and move this 16 over to the other side. I'm going to subtract it. So 225 minus 16 is 209. Obviously, this side cannot be 209. This is a short side and this is a short side. Hypotenuse is the longest side. So we have to do something to this. This is letter B times itself, or the side length B times itself. So in order to figure that out, I'm going to take the square root. I'm going to undo the squaring. So putting that into my calculator. Okay, I'm going to go second square root 209, enter. And again, I'm going to get something kind of ugly, irrational, 14.45683, blah, 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 blah. And when I round it off to the nearest hundredth, 14.46 is my final answer. All right,